we're going to continue on with volume, but today we're going to talk about volume of pyramids and cones. So to kind of start off here, there's really only one difference between finding the volume of a prism and the volume of a pyramid. And it comes from kind of this picture here. So let's say we had a cube, so a square prism, okay? And I had a pyramid that had the exact same base, so it's also going to have a square base, and it has the exact same height, so you could like fit that pyramid just right inside the that cube there. If you were to take that pyramid and like tip it over and fill it up with water or sand, pour that into the cube. That sand or water would fill up exactly 1/3 of the cube. Every single time. It doesn't matter if it's a square pyramid and a square prism. It could be a triangular pyramid and a triangular prism. Or it could be a cylinder and a cone. If they have the same base, congruent bases, and the same height, the volume of the pyramid and the volume of the cone are going to be exactly 1/3 of the prism or the cylinder. So the formulas today are the same, except we're going to throw 1/3 in front of it. That's it. Okay, so let's try this one here. I would say really the only difficult thing today, kind of like yesterday, the formula is super simple. The difficult thing today is if you don't have the information that you need, that you're just finding that information that you need, which is not a whole lot different than what we did yesterday. So starting with this pyramid here, just like yesterday, to find the volume of a pyramid or of a cone, we have to have the area of the base. When we talked about surface area, one of the things that I mentioned to you that it said in the book, but I didn't write it in your notes, was that unless they say otherwise, tell you, you can assume that the pyramid is a regular pyramid. So since they just have one of the sides marked as 40, they don't tell me what the other side is, we can assume that all sides are 40, so this would be a square. So to find the area of that square base, what would we do? 40 times 40. So the area of the base would be 1,600.
When are we going to use the 1/3?
Well, we're just finding the area of the base. Now, to find the volume,
1/3.
this is where we're going to take 1/3, the area of the base, which is 1,600, times the height. The height of the pyramid, which I don't know, because that 25 is the slant height. I need the height, or otherwise known as just height. Okay, how tall is it, right? I need that measurement right there. So, most of your applications today are going to be, how are we going to find the height? Pythagorean theorem. Right, we have those special right triangles, but you can only use the special right triangles if you know the angle measures. I don't know the angle measures here. So we are going to use the Pythagorean theorem. Now this is a tiny bit different than whenever we did surface area, because when we were doing surface area, we were looking for the slant height, which is always the hypotenuse. So we took something squared plus something squared, added them, square rooted, there's your answer. But this time I have the slant height. I have my hypotenuse. So it's going to look just a little bit different when you plug your numbers in. So you need that side length right there, and be really careful here, because I had one of these on your quiz that you guys took on Monday, and I had a ton of people miss this one. What is that measure on the bottom of that triangle? 20. The whole side is 40, it's just half of it. So the Pythagorean theorem says if you take the sum of the squares of the legs, so one of the legs is 20, so we're going to square it. The other leg is h, so plus h squared, I don't know what h is, equals the hypotenuse squared, that 25 squared. So notice, it's still the Pythagorean theorem, but my numbers are just in different spots. So 20 squared is 400, plus h squared, 25 squared is 625. Now to solve for h, we need to move that 400 over. So we would have h squared equals 225, square root. We should get h equals 15. So the height of my pyramid is 15. So to find the volume, we take 1/3 of the area of the base, which we found was 1,600, times the height, which we just found is 15, and we should get 8 1,000 feet cubed. Super similar to yesterday. Now, also similar to yesterday. Remember how we learned about that really cool cat named Cavalieri? Remember that guy? Okay, and this Cavalieri guy said that if you have a right prism and you compare it to an oblique prism, if they have the same height and equal areas at every cross section, then they're going to have the same volume. Cavalieri's principle works for prisms and cylinders. It also works for cones and for pyramids. Keep these words separate here. So, although this is an oblique cone, I can still use the same formula. We are going to start, just like we did with yesterday, we're going to start with finding the area of the base. Since it is a cone, the base is a circle, so hopefully we know by now. How do you find the area of a circle? Pi r squared. So pi times, what is my radius?
15.
15. So we get 225 pi. So to find the volume, we are going to take 1/3. The area of the base is 225, forgot my pi there, 225 pi. Now remember, it needs to be the height of the cylinder. So you're talking about planes here. So if you look at the bottom as a plane, and where that top is a plane, you're looking for the direct distance between those two. That would be it this time, okay? If it's oblique, it's not going to come down to the center, but it does come down to the base. Okay, so my height is 25. Let's just leave it in terms of pi, so we would get 1,875 pi feet. That's all we want today. That's very simple today. Okay, let's get this glued into page 59, section 11.5, volume of pyramids. Okay, let's go ahead and let's get going here. So I put on there a square pyramid. We're not going to do a square pyramid. Actually, this first one is going to be a triangular pyramid. And actually, the base is going to be an equilateral pyramid. So an equilateral triangle for a base. Oh, it's kind of hard to draw a little bit. Should kind of get the end of it. Okay, this side is going to be 10 centimeters. And then if I go from the top straight down, that is going to be 12 meters. So just like yesterday, we want to start by finding the area of the base. And we already said the base is an equilateral triangle. So to find the area of a triangle, we take 1/2. The base, what's the base of my triangle? 10 times the height. Remember, it's the height of your triangle. Okay, I don't know it yet, right? It would be, you guys are ruining my little flow here, okay? So, I would need this right here, which we did one of these yesterday. If you look at this, okay, I can create these two separate right triangles. I'm looking for that side there. So if I look at this big angle before I cut it in half, we did this yesterday. All of the angles together are 180. Divide that by 3. The big angle would be 60. Cut it in half, so it would be, when you cut 60 in half, you get 30. Okay, so I have a 30, 60, 90 triangle. This side here is that side that I want, and it would be 5, which is the shorter leg, since it's across the 30-degree angle. So the longer leg, the height would be 5 square roots of 3. So to find the area of your base, you would take 1/2 of 10 times 5 square roots of 3. Half of 10 is 5. 5 times 5 is 25 square roots of 3. So I have the area of my base. Then to find the volume, it's the same formula as yesterday, except we're going to throw that 1/3 in front. So we're going to take 1/3 the area of the base times, now remember you have to have the height from the base straight up to the top. Do I have the height?
Yeah.
This time I do. So we would multiply that by 12, and if we were to round this, we should get about 173 centimeters cubed. So maybe a few special right triangles sneaking it up. Love you. Very well. And it's reciprocated love, because I know you guys love these special right triangles. Okay. All right, number 2. All right, let's do a square pyramid. There we go. Square pyramid, which means we have a square base. Okay, one side of my base is going to be 18 yards. Then from the peak down to the edge, that is going to be 15 yards. So similar to yesterday, we want to start by finding the area of the base. My base is a square, so how will I find the area of my base? 18 times 18, which would give you 324. So then to find the volume, we take 1/3 the area of the base, which we said was 324, times the height of the pyramid. Do I have the height? I have the slant height. I need to find this right here, which once again, I've created a right triangle. I know two sides of my right triangle. I have the hypotenuse, right, the side opposite the right angle, and I have this base right here. Be very careful here. What is that base right there? 9. Okay? So be very careful when you're plugging these in, because I have my C, right? It's going to be equal to 15 squared, okay? To find the other ones, we are going to take 9 squared plus, I'll call it h squared because it's my height, equals my hypotenuse squared, which is going to be 15 squared. So we get 81 plus h squared equals 225. Move that 81 over. We get h squared equals 144. Square root it. We should get our height is 12. So we'll plug that into our formula right here. So to find the volume, we would take 1/3 of 324 times 12. We should get 1,296 yards cubed. So similar to yesterday. Okay, just throwing that 1/3 in front of your formulas. Questions on the pyramids? Okay, so let's move on to the cones. Kind of like yesterday, we're going to find the volume of the cone in terms of pi, and then we will estimate to the nearest cubic units. Okay, so let's say we've got a cone, an upside down cone here, all the way across is 8 inches. And then when you measure down the side, it is 11 inches. Now it's the same process as the last one. You always want to start by finding the area of the base. But for a cone, your base is always a circle. So, how do you find the area of a circle? Pi r squared. What's my radius?
4.
4. So we'll take pi times 4 squared, which would give me 16 pi. So to find the volume, just like with the pyramid, we are going to take 1/3 the area of the base, so 16 pi, times the height. Do I have the heights? No, I have the slant height, right? The height would need to go from that vertex right there straight up to the top. Okay, so like the other ones, we get this right triangle. Just like the other ones, this right here, my slant height, that's your hypotenuse. Okay, it's going to be equal to 11 squared. One of your legs, that leg right there is what? 4. Right? Be very careful with that. So to find my height, we are going to take 4 squared plus the height squared, and I don't know what that is, equals 11 squared. So we would get 16 plus 8 squared equals 121. Move the 16 over. So 8 squared equals 105. Then square root it. Should get about 10.25-ish. Got to round on that one. So I can take that, plug it into my formula over here. To write it in terms of pi, you're just going to multiply the numbers, not including the pi. We should get about 54.7 pi inches cubed. And then if I want to round, we plug the pi in, should get 172 inches cubed, about. Once again, have to round there. All right, and last one. Okay, number 4. Okay, now this time it's going to be like one of those little water cups, but this comes from like the defective pile of those water cups because it's not right. It's like slanted a little bit. Like these ones didn't actually get put in production. Yeah, this is a little messed up snow cone thing because it's like off to the side. It's an oblique cone, right? They don't put these on they just give these away. Anyway, okay. And it is a massive snow cone because it's 16 inches across. Okay. And then from here all the way up there, it is 15 inches tall. That is a heck of a snow cone right there.
I would feed my dad.
Now remember, even though it's oblique, you use the same formula. You want to start by finding the area of the base, which is still a circle. So we would do pi r squared. What's my radius? 8, which gives me 64 pi. So then find the volume. We take 1/3 the area of my base times the height of my massive snow cone, which is 15. They give it to me that time. So in terms of pi, you get 960 pi inches cubed. Estimated to the nearest cubic inch would be 3,016 inches